How are you everybody? How are you today? This is the 8th lecture related to advanced mathematics course. This is for 4th year English statistic section in Banha University 2020. And I want from every student to study this lecture very closely because this lecture related to the 5th part in the integration process and the integration procedure. Because there are some mistakes and many mistakes in integration, I want from you to study this lecture very closely to make a differentiation and know the difference between the different aspects of integration. Integration part 5. This part again related to many important aspects and procedures and steps about integration part. This is part 5 in integration course in advanced mathematics, and you must know the different aspects of integration and make a differences between integration steps and the integration process, and every student must to know the differentiation between integration, because many examples can be solved by the same rule and many examples do not apply the same rule, so that you must know the rule and the right rule to make a right result, to make a reasonable result, not a misleading result. If you do a wrong and apply a wrong rule, it's 100% the answer must be misleading. So that carefully study this lecture to make a differentiation between the different aspects of integration. Examples. By differentiating the following functions, write down the corresponding statement for sine 3x 2x plus 1 to the power 7 e to the power x to the power 2. Solution. D by dx sine 3x equal cosine 3x multiplied by 3. So cosine 3x 3 dx equals sine 3x plus c. du by dx 2x plus 7 plus 1 to the power 7 equals 7 2x plus 1 to the power 6. So integral sine 7 2x plus 1 to the power 6 2 dx equal 2x plus 1 to the power 7 plus c. d by dx x to the power x over 2 equal e to the power x over 2 divided by 2x, so that integral sine e to the power x over 2 2x dx equal e to the power x over 2 plus c. This is an illustrative example to know how we can make integration and differentiation. Exercise 7.1. Differentiate each of the following function and then rewrite each result in the term of the statement about integration. 2x minus 4 to the power 13 sine by x e to the power 3x minus 5 ln 2x minus 1 over 5x minus 3 tan 5x x to the power 5 minus 1 to the power 4 sine x to the power 3 e to the power square root of x cosine to the power 3x tan x to the power 2 plus 1 ln sine x. The next step is to learn to recognize when a function has the form f dash gx multiplied by g dash x, that is when it is the derivative of a composite function. Look back at each of the integration statement above. In every case, the function became integrated is the product of two functions. One is a composite function and the other is the derivative of the inner function. In the composite, you can think of it as the derivative of what's inside the brackets. Note that in some cases this derivative is a constant. For example, consider e to the power 3x multiplied by 3 dx. We can write e to the power 3x as a composite function. 3 is the derivative of 3x, i.e. the derivative of what's inside the brackets in e to the power 3x. We can write e to the power 3x as a composite function. 3 is the derivative of 3x, i.e. the derivative of what inside in the brackets in e to the power 3x. This is the form. Integral sin f dash gx multiplied by g dash x dx with u equal gx equal 3x and f dash u equal e to the power x, e to the power u. Using the chain rule in reverse, since d by dx f gx equal f dash gx multiplied by g dash x, we have integral sin f dash gx multiplied by g dash x dx equal f gx plus c. In this case, integral sin e to the power 3x multiplied by 3 dx equal e to the power 3x plus c. If you have any doubts, any worry about this, it is easy to check if you are right. Differentiate your answer. Now let us try another. Integral sin cosine x to the power 2 plus 5 multiplied by 2x dx. Cosine x plus x to the power 2 plus 5 is a composite function. 2x is the derivative of x to the power 2 plus 5, i.e. the derivative of what's inside the brackets. Again, cosine x to the power 2 plus 5 between brackets x to the power 2 plus 5 between brackets is a composite function. 2x is the derivative of x to the power 2 plus 5, i.e. the derivative of what inside the brackets. So this is in the form. The previous example is in the form. Integral sin f dash gx multiplied by g dash x dx with u equal gx equal x to the power 2 plus 5 and f dash u equal cosine u. Recall that if f dash u equal cosine u and f u equal sine u, so integral sin cosine x to the power 2 plus 5 multiplied by 2x dx equals sine x to the power 2 plus 5 plus constant c. Again, check that this is correct by differentiating. People sometimes ask, where did the 2x go? The answer, back, where it come from. Again, check that is the correct answer by differentiating. People sometimes ask, where did the 2x go? The answer is back where it come from. If we differentiate sine x to the power 2 plus 5, we get cosine x to the power 2 plus 5 multiplied by 2x. So, when the integrate cosine x to the power 2 plus 5 multiplied by 2x, we get sine x to the power 2 plus 5. This is the ending. This is the end of our lecture. See you in the next lecture. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.